Hello, this is Mr. Huff. Let's talk about this formula. This formula is for calculating the runoff rate represented by the letter Q. We also have the runoff coefficient adjustment factor, which you have to look up based on the design of your storm. So if you're using a 1, 2, 5, or 10-year storm, you use a coefficient or this adjustment factor of 1. If you use a 50-year storm, you use a adjustment factor of 1.2. So you use this little table to find this number based on what your question is asking or the design storm you're choosing. Okay. Then we get to the runoff coefficient, and this is from this table on your PLTW engineering chart. There's also, these occur all over the place online, so you can find this information. So in the questions you'll be answering for me, I am providing the information to you. Notice that it has a range. Let's look at brick, for instance. If it doesn't specify, well, if you know a lot about the site, about the amount of the brick and the kind of brick and the spacing of the brick and all that kind of thing, then you can get a really specific value here. So this is an expected range. If you don't have the specific information, then you will use an average of these two. So you add the lowest and the highest together, divide that by 2, and you can find the average coefficient. If the problem says use the conservative coefficient, then you're going to choose the highest number, and that's going to give you the highest runoff rate, which would be the most conservative. Okay, so that's how you use these numbers. In most of the problems I give you, I'm giving you a specific number. Okay, so that's how to use that. Next one we see is the rainfall or precipitation intensity. This is represented by the letter I. This is how you find it. You can go to this website. It's a NOAA. This is what is this? This is it's a the National Weather Service. That's what I'm trying to think of. So you can go to this website and you click on the state you're interested in. So here we go. We'll click on Texas. And we are really interested in precipitation intensity. So we're going to choose that on this drop down, maybe. And then you can either put in a specific address or drag this little pointer around to where you want and then zoom in on that. So now we're going to look at Austin. Give my computer a second to catch up here. But what we're looking for, so this is Austin, what we're looking for is this table. Okay, it also gives you this information graphically. They're logarithmic table or graphs, and they're a little tricky to read. It's easier to use this. So you're going to look at the parameters for your design storm, the average recurrence interval in years, and the design duration of your storm. So you would find, if we said 25-year storm and a 2-hour, so 25-year, 2-hour storm, you're going to find 25 years, and then you're going to go down here until you see the 2-hour storm. And it gives you a range here from 1.77 to 3.28 to let you know the boundaries. But the number we will use for this information would be the bolded number. So that's what we would be interested in, is this number. Okay? So back to this. And the last number is area in acres. So let's talk about units in this formula. Q is cubic feet per second. These coefficients are unitless. The rainfall intensity is in inches per hour, and the area is in acres. This is a formula where dimensional analysis doesn't work. You can't do cancellation to find your final units. It's more based on observation and a relationship between these values. Okay, and in the notes it goes into it in some depth, but the units do not cancel out. You can't use that strategy. So this is a strange formula. All right, let's do an example problem. This is an example of how you would write it down. So I didn't actually write the problem, I just collected the information from it. So this is telling us that it's a design storm of 25 years. So our adjustment factor is 1.1. Our coefficient for the runoff is 0.6, and we would have gotten this from that table, the PLTW reference table for the runoff coefficients based on surface, or it could be a composite coefficient. Our value for rainfall intensity is 1.41 because we looked it up for the site, and our site is zero point 0.8 acres. We are solving for the runoff rate in cubic feet per second. And then we're going to use the formula we just talked about. So we just plug all the numbers in. We have the adjustment factor times the runoff coefficient times the rainfall intensity times the area of the lot. We plug that into the calculator and we get 0.74448, and that leaves us with a runoff rate of 0.7444. I like four important numbers. I don't really care about rounding or significant figures or all that stuff. Just give me this, and that way you will, if you do that, the way I set up the formulas, if you round a little high or a little low, it's still going to be just fine. So, and that is in cubic feet per second. Remember that when you do this, you have to have units for the unknown and for the solution. All right. So this is how I expect your work to be documented for these. All right. That was kind of lengthy, but thank you for listening.